Good morning, everyone. Thank you for being here early on the Friday, especially my American compatriots. For us, it's the middle of the night, but we did it and we're here. So I'd like to welcome you to our lightning talks and research panel on FDO-based solutions to foster data science. We have 6 lightning talks, and we have an order that we might need to switch up. I don't think Erik Schultes is here yet. Okay, each lightning talk gets 5 minutes. Then we'll move to panelist statements and discussion. So we will begin with Yvonne Anders from the German Climate Computing Center, Nifty for Earth.
Yeah, so good morning. As Christine said, I'm working at the German Climate Computing Center, and we are not only a computing center with offering infrastructures, we also hold the World Climate Center for Data. For climate, sorry. Actually we have very important data set there. It is the CMIP6. I don't know whether some people heard about this. It is actually, oh, I saw a hand there. It's actually the most important climate data at the moment. So whenever you see some information about possible future climate change, it's actually based on these kind of data sets, or this data set. And so you can imagine this climate information is quite important for the whole society. And this data set, we are quite close to fair with this, so it is following standards, and it's of course important that people from different disciplines understand this data set and can use it for their research or climate services, etc. So our let's say customers or researchers, we have using the DCARZ infrastructures, they do climate modeling or ocean modeling, and they the models develop quite fast at the moment, so they increase the temporal and spatial resolution, and actually it ends in a huge amount of data. And we have now the problem that it's not possible to handle this data anymore. It's just too large to even write the data or store the data or visualize or something like this. So we analyzed the workflows of the different users we have, and including the publication procedure. And we identified that for the different users, independently whether they are modelers or reusers of the data, some parts in the workflows are similar. So we actually have the vision to, if you imagine the different workflows and parts are the same, we would like to, or our vision is to take parts, or the whole workflow could be single FDOs. So we see that if you have the workflow as parts of FDOs, probably we do not need to store the data in the end. So if you store or save the workflow, it is probably quite easy just to repeat the workflow instead of holding all the data. So if a person wants to, of course these quite large simulations, it takes some years to do, but for smaller things it would be quite nice to do it. So and also the FDOs for us would improve this procedure of provenance tracking and make research actually transparent, more transparent. And also we have the opportunity to take some parts out of the workflow and do something different, so, and repeat the whole workflow to create new research also. But of course we see limitations of this workflow as FDOs or parts of the workflows because of with respect to reproducibility. We have, probably you know, so if the machine disappears also, it is not possible really to reproduce the research really, or to use the code again and get the same results. We also see some limitations, especially across disciplines. As I said, these data sets are quite important for different disciplines. So it is quite hard to include or to make data understandable for different disciplines. And we worked, so this climate information is quite important for other disciplines. We, as a Earth system or simulation-based Earth system science, are quite far with standards, etc. But other disciplines, sometimes there isn't even sharing popular, so they do not even share data. So they are quite on different levels, different disciplines. And our biggest challenge, we see that we're talking a lot about FDOs, how it could be created, whatever. But it's very important to work together with the different communities right from the beginning, because otherwise, probably it's, and they also need some examples. We also mentioned at different times. So to give some examples that they see the benefit and to include it in the whole process from the beginning, it's the thing we should go for. Thank you.
Thank you so much, Yvonne. And now I'd like to invite up Erik Schultes from GoFair International, who's also leading the session in the next room. So thanks for splitting duties.
Yeah, talk about parallel sessions. This is really a parallel session. Good morning, everybody, and thank you to the organizers for an opportunity to give you this presentation. What I'd like to mention today is that while working with fair implementation profiles and trying to develop means of making them much more machine actionable, we ended up developing a tool, we call it the FIP Wizard, which allows ordinary everyday people to author nano-publications. And those nano-publications can then be accumulated into lists that become the fair implementation profile. So we got to a point in this very limited domain where people were very successfully minting new nano-publications specific to that area. So we started working more and more with nanopubs. We saw all kinds of nice services running nano-publications, and it became really kind of an intuition or a wake-up call, like, wow, this is really interesting. It almost feels like we're doing something FDO-like. And we started thinking more and more deeply about the relationship between FDOs and nano-publications. I had a presentation yesterday with my colleagues, session 3A, I think, where we tried to make an argument. We tried to present some evidence that some of the nano-publications we're doing in the FIP Wizard are actually conformant to the FDOF specification, or as close as we can get to it today. Okay, so that's interesting. Some nano-publications might actually be FDOs. What that means is that because these services are already running and we're learning how to work with FDOs, that in a way, we're kind of doing FDOs right now. So the next step was, and this is kind of the heart of what I want to mention today, in May of this year, we ran a workshop at the GoFair Foundation called the Fair Wizard of Leiden. And the idea was to take our FIP Wizard, which makes nano-publications for FIPs, and to generalize that as kind of a general nano-publication publication tool. And we gathered up some research scientists from the greater Leiden academic community and some data stewards, and we gave them a one-day intensive training on the FIP Wizard and on nano-publication authoring, et cetera. And we said, okay, if you can manage this, try going back to your lab and see if you can implement, in some way, nano-publication representations of your own data. And so for some groups, this was too much. It was a little bit overwhelming. I think there's a lot of room for improvement on the technology, obviously. But there was a group at the Leiden Academic Center for Drug Discovery that practices high-throughput data generation and metabolomics. And so they're already used to building pipelines and doing very technical things with big data. And they went ahead and really gave this a good try. They haven't yet created nanopublications in their workflow, but it's only because they're being very careful to try and figure out how it fits in to their workflow. And I thought I was gonna have an opportunity to present a slide. and they have a very beautiful list of kind of open questions that they've encountered in this. So there's a slide somewhere at the end of there. And it's going to be right there. Oh, look at that. Okay, there's a fair wizard of light and meeting. And these are the slides that those data stewards produced. And we, just in the interest of time, I won't go through all of them, but these are the questions. They were trying to verify some data elements from previous publications. And I just want to highlight 3 questions that they ended up with. How do we mint thousands or millions of nanopubs and keep track of them? It's not going to be manually in a FIP wizard. It's going to be other means. How do we automate the process to ease researchers' workload and diminish incensant redundancy? So a lot of these nanopublications are extremely redundant, right? They're collecting values, but all the provenance, for example, is the same. So what are good methods for kind of managing that redundancy and really getting performance out of these systems? And how do we make both flexible and standardized templates for minting collections of nanopublications? And I think that's also a main concern of digital objects from the beginning. So I'll leave you with that. You can examine the slides more closely if you want. But I just wanted to say, we started to see this relationship between nanopubs and FDOs, and we already have a lot of tooling built up around nanopubs. So I think we're already beginning to get a snapshot of what a world of FDOs might look like in practice for scientists, at least in a light and academic community. So thank you.
Thank you so much. And now I'd like to invite up Amir Mozaffari from the Jülich Forschungszentrum.
Thank you. Hi, everyone. I'm Amir from Jülich Supercomputer Center. And actually there we do 2 tracks in my group that we do 2 tracks of work. One is related to air quality data sets. We are hosting the biggest tropospheric ozone data sets in the world. And one of the biggest challenges that we have there is if you ever work with experimental data, that is a continuous stream of a data. Behind it, you have the waves of new data comes, correction comes, modification, new station comes. Like you have multiple versioning coming from the same data sets. So for us, we see a FDO as a vehicle that we can answer this systematically, that how we can versionize this data, and we can go back to it. And so we were developing the idea of using FDO as a caching system using FDO. And I said we are a supercomputer center, so it means that we are using supercomputers. So of course, in this chain should be part that schedule big jobs on HPC system. So we're interested in this link at the same time that we cache the data that we have. Since we produce lots of statistical data, we aggregate lots of information. These things need to be also communicated, go to the HPC systems, comes back, informing our users. So we see FDO as a vehicle can do this for us really elegantly. And the challenge that we see is also, what I'm missing is an applied FDO solution. Doesn't matter how rudimentally, but just some things that we can start on it. That I had a chance today that talked to Rainer, and I heard that there is implementation in KIT, that they already have some profile that we can start. What I really missed so far was somewhere that I can go and say, we applied this version, try it, put your hands on it, and gives us some feedbacks, and to be a little bit more less abstract about some idea in the air rather than some things a bit more hands-on experience. And thank you.
Thank you so much. I'd like to invite up Sara El-Gebali from SciLifeLab Data Center.
Okay, hi everybody, good morning. So I'm Sara El-Gebali, I'm from the SciLifeLab, and I'm also the co-founder of Fairpoints. I've seen a lot of technical talks and technical people come here. I'm not one of them. I'm going to offer another point of view that is extremely important for the future of the FDO. And I'll start off by one of the comments or things that was mentioned by George Strong yesterday, where he said the fair digital objects originated in the scientific community. So did the internet. And I want to emphasize here the word community, because community lies upstream and downstream of the FDO process. We need, we do need community to generate metadata. It doesn't come out of thin air. We need community to ensure that there's consensus, and we rely on the community member to have this reporting guidelines and everything that we need. So what I would like to emphasize is that the community members play a critical role. Without them, there's no metadata. And this is also hard work, so we need all sorts of people in there. It takes a whole village. And downstream of the FDO process as well, we need community, because without their buy-in into the technologies, the services, and tools, we'll achieve very little on the adoption side. So I'm reminded of one of the questions that was posed by Arfan in one of the sessions from yesterday, is, do we build it and they will come? And then what happens if they don't? So who do we have here in the room? Do we have technocrats, people who believe that artificial intelligence, machine learning, and other technologies are going to solve world hunger? Or do we have a diverse group of people that cover all perspectives and everybody that we need on the team? We need to examine our ecosystem. Remember, as Maaike van de Kaap, the director of this beautiful place here, she mentioned yesterday that ecosystems are critical to our survival. It's crucial that we take stock of what's around us, and more importantly, what's not around us, lest we wake up one day and find out that 75% of our ecosystem vanished. So it's an important point to consider, and I encourage you all in this room to look around and try to answer the question of, do we have everyone we need to achieve our goals? And by everyone, I mean, one obvious answer is the researchers. We need to have the researchers on board. We also need research support staff. Baron mentioned we need about 500,000 of data stewards. But we also need infrastructures, providers, and tools and services builders. And on top of that, we need to look for a much wider engagement from a much wider community. Because we as human beings, as the creators of data, we don't live in siloed communities, right? And there's an incorrect and potentially harmful assumption that certain regions in the world produce less data than others, like low middle income countries. And this is why I say it's harmful, because we assume that data production is static, it's not affected by external factors like, a pandemic. We assume that scientific growth is constant without taking into account increased investments. And more importantly, we've seen the consequences of not including low middle income countries in the open science discussions early on. We're paying a heavy price for that. So I'm not gonna go too much into this, but I wanna refer you to an article by Louise Bissentoot, which is titled Hidden Concerns of Sharing Research Data by Low Middle Income Country Scientists. So in light of our efforts to create a globally integrated data space, I feel it's important to point out that excessive homogeneity can stifle innovation, leave us vulnerable to critical blind spots. So we need to look around us, acknowledge that we need creative, talented individuals from diverse demographics. We need to make our spaces, conversations, and collective knowledge more accessible in order to inspire and guide and motivate younger generations. Finally, we must work on replacing obsolete attitudes with better practices and behaviors, with accessibility, kindness, and togetherness. So take stock of your surroundings, assess the health of your ecosystem, and think about how you might want to improve it. So thank you.
Sara, real quick, how do people find the time and place for Fairpoints, something that you've been hosting monthly?
Yeah, thank you so much. So Fairpoints is one of the initiatives where we're trying to bring the diverse voices from people, not just from the infrastructure point, but from the researchers, from all demographics and across disciplines, to hear about how they are applying FAIR in reality, how they could be doing fair things without even calling it fair. And that's the conversation we try to bring in. We also try to make the conversation summaries interoperable. We have embedded schemas. We've built fair digital objects out of these. So I hope you can see some of our work and to join us and go to fairpoints.org. Thank you.
Awesome, thank you so much. Now I'd like to invite up Jan Schweikert from Karlsruhe.
Thank you very much. So yeah, hi, I'm Jan from Karlsruhe Institute of Technology, and I'm working at an institute where we do a lot of energy research, and basically we are developing a co-simulation platform where we can analyze optimizations of energy management systems in supply networks. And what we do there is the energy management systems is talking to the producers and storages in the simulated network and tell them how to act given different demand profiles of consumption or at least weather conditions. And our visions with FDOs is that I can open up my browser, go to some indexing service where I can search for demand profiles or different weather condition data in a really sophisticated way. So we have a lot of filter criteria where we can filter the data out. And similar to like I do my paper search, but with a lot of more filter options. And then I will drag and drop this data just in my simulation and start the simulation, get my results, either will publish these results as well as FDO again. But what I want to say. But all the handling of the PID resolving, all the middleware calls, handling protocols, or even extracting data out of larger data sets to fit in my simulations. This should be handled by the computer itself without any involvement of the user. So it's totally transparent for them. And I think this can be possible with FDOs. So FDOs, in my opinion, are somehow management objects that allow us to interconnect repositories in a normalized way. And maybe you also can think of FDOs, in my opinion, like artifacts of a meta data management ontology. But also to connect repositories, we need repositories. And from the work in HMC, where I'm participating in, I see a lot of different it's really different depending on the research fields. If they have good repositories with a lot of data in it, with a lot of metadata description in it, or if they're just starting to develop repositories, start developing standards, doing metadata stuff. And for all the people who are just starting with this subject, FDO is maybe the goal, but do it one step after the other, because running through FDOs will get you in a jungle with missing specifications, missing guidelines. You need to explore how to do things because it's not clear enough. at the moment. And so at least if you don't get the fair DO, try to reach a IDO, just the interoperable part. And on this way to the fair DO, develop a lot of software, because I think software that allows to use the data, allows to create metadata is much a better incentive than just to say that people go do fair DOs. Yeah, that's everything for me.
Thank you so much, Jan. Now I'd like to invite up Mark Wharton from IOTICS. I hope I didn't make up how to pronounce your acronym. Okay.
No, IOTICS is fine,
Oh,
but we are
perfect.
from the UK and not from the US.
Okay.
Hurrah! We drink tea and we like cricket. After Sarah's impassioned speech, I feel a bit embarrassed to come and stand up here as a pale, stale and male, but then I thought to myself, there's more than one kind of diversity. So I'd like a show of hands, please. Who is from a commercial software organization in this room? Oh, that makes two of us. The days where the academic community can change the internet went away in 1985, 1990. This is an amazing group. I really enjoyed this week. And I've thought of lots of different perspectives. And I'm thinking there's Erik talking about his nano publications, there's the DOIP, and there's the work we're doing with digital twins. And are they all the same thing? Is it just a reinvention of the same wheel? Or some people making axles and some people making suspension? Are we trying to force things together that fit together? Or are we trying to push two north poles of a magnet together to make things work? And I'm sorry if I'm going to ramble a bit because there's a lot of thoughts in my head. That isn't it okay to let it evolve like that? Because I think the previous speaker over there was talking about, isn't it nice to see something in action? Well, we're doing it. I'm a builder, I'm not an academic. I like to make stuff. And we've done it with some universities in the UK where they have automated test cases running. They have a program which runs, puts the automated test case results into a database, builds a digital twin of that test case and publishes it in a decentralized data sharing space, which is what IOTICS is. So we're doing it. That's the thing I think you want over there. He's not looking at me, but yes. But we're doing it in a different way. But if we treat fair data as a kind of an overlay layer, like somebody said, some principles, perhaps we can unify all these different things that are going under in that one layer. You know, abstraction layers solve all problems in software, they say. So we can think of it like that. If the fair data principles work on top of that, it doesn't matter whether you're using it with DOIP or whether you're using it with the nano publications or digital twins. Perhaps we can unify in that kind of way and allow the diversity. Because the one thing that worries me, the other point I wanted to make is about money, is the work we did with the universities in the UK, we did for free. And we learned an awful lot, they learned an awful lot. They've even built an ontology for their test cases, which is a huge step forward for them. And they said they used to lose friends because they would get the wrong test case results and waste a whole lot of time. Now they've got an ontology, they can recognize exactly what the use cases are. Now, we did that for free. I hear everybody in this room talking about funding for this and funding for that. And that really worries me, in that you'll get a bit of funding to do a something, and you'll do that something, and then the money runs out. And then you do another thing, and you think, oh, that money's run out of that. So I really think you ought to open your doors a little bit more to the commercial software vendors, because they're probably going to help you to build this at the scale that it needs to build. And I really support this. The whole idea of the global integrated data space is something I've been working towards for 10 years now. And I didn't realize all this first happened until about 6 or 7 years into that 10. So, you know, it's not just you guys who are thinking about this. And I want to just say one more thing to reinforce what Sara said, which is involve your users. The other thing I've learned over the years is if you lead something by technology, and he said, oh, this is a technology that will solve your solutions, most people will ignore you. And they'll say, oh, what cool tech, bro. Or they'll go, doesn't do anything for me. So I really think there's a great example, the Data-Centric Architecture Forum. They're terrific people in Colorado, you ought to look them up. They have two conferences. They have a conference for people who do, and they have a conference for people who want. And I think that's what Sara was saying. Involve your researchers, involve the people who are going to use this stuff. Maybe two conferences isn't the right idea, but definitely have as part of this forum a different set of voices, the people who want to use this stuff rather than the people who are making it. Okay, thank you very much.
Thank you so much, Mark. I know when you asked how many people are doing commercial software, it was 2 people. But if you had asked how many people are open to commercial software money, I think you'd have a lot more hands. So I'm sure people are happy to work with you and others. Yeah. Okay, so now we have 4 panelists. I propose that we have them come up one at a time. When you're finished speaking, you're welcome to take a seat, choose where. Hopefully you are mic'd up. If not, we will figure it out with this mic. The first panelist is Zeyd Boukhers, a research fellow from Fraunhofer Institute for Applied Information Technology. Perfect. And we have about 5 minutes per panelist, and then we'll go into some questions.
Hello, everyone. Thank you for, so I don't need the mic. Thank you for having me here. Actually, I would like to start from where we left off yesterday, where Barend mentioned that up to 85% of data is not used or not reused. And I would like to add to that 90% of the publications are never cited. I think in data science, the percentage is even higher because the number of publications in data science is above average across disciplines. And some people might argue that this is due to the quality problem. That might be the case, yes, but not for 90% of the publications. And as mentioned in many talks, the problem is the reproducibility, how we can reproduce the result. I believe that most of the researchers cannot even reproduce their own results, even when following the best practices. I think I'm one of them, unfortunately. And so, actually, I forgot where. I think there is no unique solution to this problem. I mean, we can come up with several solutions, and every community can propose its own solution. But this is expensive and complex. And the FAIR concept gives us actually a semi-ready solution to this. So why not investing in working on the FAIR concept and including it in the data science workflow or ecosystem? And why I believe that FDO is the solution to this, here I will quote the European Commission experts group, which defines FDO as the atomic entity of a FAIR ecosystem. So if we want to make a FAIR an ecosystem FAIR, then we need to make its entities FAIR. This applies also to data-driven ecosystems. And if we break down the data science workflow into elements, what we will have? Basically, digital objects. We'll have a software or a code. We have a data set. We have a publication, which represents the result, and so on. So, therefore, I believe that FDO would boost data science reproducibility and would help the data science community to make the data science ecosystem sustainable, maintained, and fair. Thank you very much.
Thanks so much. Now I'd like to welcome up Hans-Günther Döbereiner, Professor of Physics at the University of Bremen.
Thank you. Okay, so I think we need to think transdisciplinarity what we have to do is leave our silos and go to the other silos and drag people out of their comfort zone. Because I think facing the challenges of the 21st century, we need to combine our knowledge. And that's where fair digital objects help in two ways. First, they provide a basal universal standard so that I can access and work with data sort of with the same tools because I find them to work with. And once I have this globally connected data space, what that will do, together with AI, it will allow us, once you have been dragged out of your silos by your colleagues, basically to understand the other colleagues' discipline. I have done that since 2015. We have in Bremen, now I think we are 62. Number 62 is invited in November. And they talked about decision making and information and structure formation. And so there are about 40 different disciplines. And that opened the view, and I think you see the way that a lot of solutions lie in the other field, and you just don't look at it because you don't know it. Or as a physicist, if you open as a physicist a book which tells you about the brain, you get a nervous breakdown. And that's the problem. And physicists have to realize that a brain is not only complex, it's complicated because it's frozen in evolution. And that has to go further. Now, people have, second, you have to think emergence. We need to stop linear thinking. There are still a lot of firms around which actually make big money out of the fact that they analyze trends. Well, we have to realize digital transformation is not going to be a trend. That's an emergent, there's a non-linear transition, and linear thinking won't help us. We have to think equality. If I may speak for Germany, we are spending $100 billion to renew our military, and $1 billion for the national data and FDI initiative. So there's in this we also within 10 years. So 1% we spend in the future, and 100% to prevent a bad future. But there is one. I think the 1 to 100 is not the right way to go. Also, I think we need to get more political. I think the transformation process is something which is not only run by technology, but it's run by getting involved into politics and explain people what the fair principles are. And by explain people, I mean, I think we have to devise different campaigns for different parts of the population. I think one academic video will not do. So we should have an array of videos which catches. Thank you.
Thank you so much, Hans, and you can hold on to that unless the next person isn't mic'd also. I'd like to invite up Anne Fouilloux, who's the head of Nordic Earth System Modeling Hub, NordicESMhub.
Yes, so sorry, but the Nordic Earth System Modeling Hub is a GitHub organization.
Oh.
And this is what happens when you change job. There is in between something you have nothing. What can I say that hasn't been said already? I don't know. I will start maybe with my journey at this conference. It has been amazing for me. It's very interesting. I have seen people for real that I've read the paper or I have willing to meet, so this is great. On the first day, at the end of my day, I was like super depressed because I heard that FDO implementation doesn't exist. And I was like, oh my God, I have a talk tomorrow and I will talk about something I'm doing. And I thought I was doing some kind of fair digital object. And I was super worried. On the second day, I learned a lot during the coffee break, that there are many implementations. And there are many things done. And people are trying, and people are evolving. It's not perfect. But as Yvonne said, we need to involve people, and we need to do things. So I was like, whew, great. I'm in the right conference. And today, from what I have heard so far, it's really what we have mentioned many times. Yes, we need to involve people. So I'm here. I'm one of them. I'm a user, and you always talk about user as a third person, and I was like, are they talking about me? Yes, you do. And you say, yeah, we need to involve them, and we need to onboard them. We need to have more diversity. We need to have more inclusion. Yes, but I'm trying. So talk to me if you want, and if you want to have more people, you maybe need to lower the threshold. I read your document. I didn't understand anything. Sorry. And I want to finish with what Sara said. It's amazing. If we want to involve lower-income countries, and if we want to have a real fair digital object world common to everyone, we need to do a bit more than saying we have to do it. We need to start. And we need to involve them, and we need to listen to them. Because so far, you are talking, and you are saying great stuff, but we need more than talks. We need action, and we need to involve them, and not to say, just come, we have done something great, look at what we are doing. Because as Sara said, they have data, they do great science, and this is the same for open science. We always say, oh, in the Open Science Cloud, we don't have users. We have many, but you don't know them because they are maybe not around you. So open your eyes and listen, and then maybe we will build a better world with fair digital objects. And I will stop here.
Oops, here we go. All right. Okay. All right, okay, it's getting lively. We're waking up, and thank you to our panelists for helping with that. Last but not least, I'd like to welcome up Lynn Pouchard, who's a senior researcher at Brookhaven National Lab.
Thank you very much, Christine, and thank you very much for inviting me, Peter, to talk on this panel. So I'm not going to add anything really new that you haven't heard so far already from the other panelists or from the conference. We had some questions. For instance, if the lightning talks in preparation of these panels were reflecting the progress in implementations. And in fact, I was quite encouraged by hearing some efforts of implementing the FDOs, in particular with the nano publications, and also that I can't see anybody have like these spots in my eyes, so I'm not used to being on stage. So I thought that some of these implementations are important, but in order to really have this effort take off the ground, I think we need to really show not only the users, but who are the users. The scientists who are going to use these technologies, some real incentives in terms of allowing them to not only to use but also to make progress. So without these incentives, and I get that in my work a lot, it's like we don't need this. Yes, thank you, and I'm going back to what I was doing before because this is what works for me, and I have been developing these habits of research for 20 years. So in order for scientists to adopt a new technology, they will really need to not only to have incentive, but to see a real benefit. That's something that saves them time, or perhaps that saves them some kind of trivial effort that they tend to delegate their graduate students to do, so the graduate students can do something else. I think George mentioned this well-known fact that for data-intensive science, 80% of the time is spent with data wrangling. So if FDOs can actually help in that respect, that would be a real benefit. And also, I'd like to discuss what Mark was saying about the people who use the technology need to be involved, as well as people who actually develop it. But it's not just two different communities. They have to come together and break down the silos, but also have a real communication effort between the two. And it's really hard. I mean, this is not something that can be done just at the stroke of a finger. It takes a lot of time, it takes a lot of effort, it takes a lot of proselytizing for the technologies. And I think that if we have FDOs as a goal and show some incentives at the beginning and small progress, but really implementations that make a real difference, that would be really a good point forward. And finally, the other thing that was really interesting also was this beginning of in a lightning talk from the person from the Jülich Center earlier, who mentioned that using FDOs for streaming technology, because it's like streaming instruments, of course, are bringing data that needs to be analyzed on the fly. So, and we also do some work with reducing performance data in order to, so it's also streaming, in reducing it in memory in order to reduce the size. So using the FDOs to versionalize these different versions, these different objects at the nano level, I think that's also an encouraging part. That's what I have to say. Thank you.
Okay, super. Thank you so much, Lynn. Try and balance on these high chairs. Harder for short people. Okay, here we go. All right. Okay, so we have some questions for our panelists, and then we'll open it up to Q&A from the audience. I'd also like to invite the panelists. If you have a burning question for each other, that is, of course, fine, too. I had one quick follow-up from one of the panelist discussions. Hans-Günther, could you say more about engaging with government and being political? Because I believe you've done some activism in your own local region, if you're willing to talk about it.
Yes, I try to balance the fine line. As a scientist, you have to understand that the way politics work. And you have to understand that you're voted, you have to win elections, and that is driving things. Second, I think one needs a relentless effort to explain relevant things and convince politicians what the important points are. And third, you have to be willing to spend all your time. and I literally mean that. I literally, for the last 2 years, I did basically nothing else. I made that choice. And I made the choice because I'm in 50s, you know, I'm getting 30 next year, 60, sorry.
30 sounds good, yeah.
You see what I would wish to become. You run a risk of saying the truth. And if you are in the middle of your career, you might not want to do that. Because sometimes if you say too much of the truth, then people might get angry at you. So you have to have a certain independence to speak up.
No, thank you. I think that is a point well taken. And actually, I think if you'd see, some of the founding ideas come from people who have already achieved tenure, have already achieved what they meant to do in their career, and they're really looking to give back and make an impact. And that's one of the things that I've really enjoyed about being part of this organization. So thank you, Peter and George, for that, and thank you for that thought. And if you don't mind, I'd like to go back to the point that brought down the house that you made. Can you think of other models in technology or science that you thought were really understandable and easy for people to implement, things that we might look to when we're reshaping any of the documents?
That's a hard question. I think when you wrote the document at the very beginning, and that's what Yvonne said, you should have included people that maybe don't understand your jargon. Because I don't understand your jargon, sorry for that. I really tried very hard, but I didn't know who to ask. So this is also a second point. If you want people to understand your jargon, you need also to have an open house discussion, maybe open cafe online, where people can come and ask silly questions, because I would have asked silly questions. And believe me, I have plenty of silly questions to ask, which I don't dare to ask, because every time I say, oh, you will think I'm totally stupid. Anyway, they know already, so that's fine. So I would, for instance, the Alan Turing Institute, they are really good at engaging with communities, and they have a path on showing on how to onboard new communities. You should look at them. I would suggest it. I look at them very often on how they do things, and I ask for advice, because they are really quite good at onboarding new people.
Well, thank you. And let me say, too, I can't imagine you would have any silly or stupid questions. I think that often points to, oh, we haven't thought about this yet, and you're out somewhere ahead. And it does sound, too, like we could learn a lot by going back and using user experience, user interface methodologies, and which involves a lot of user testing and user engagement. And it does sound like whatever you want to call it, office hours, or ways to just engage people to people, not having to consume something with jargon, would be a step in the right direction.
Yes, definitely. And I think if you present, like in 2 years, something which is very polished, very nice and fantastic, but we haven't made all this work to onboard people, you will need at least 5 years or 10 years to onboard the community, so that we understand what you are talking about, that we understand that this is useful. And I can give you, for instance, an example for data management plan. On the day I was told, now, and for every single project, you will have to write a data management plan document. And I said, what is that? Why? What for? And I found it was totally useless, but I did it. Every time I had to write some shitty document on this. And I did it because it's mandatory. But then when I started to do a bit more like open science, and I started to be interested in fair digital object, which I thought I was doing fair digital object, I said, actually, data management is great. If you do it properly, it can help me, and it can save me a lot of time. But I was never involved in this process. So when you come and you say, now you have to do it, I say, okay, another administrative task I need to do. So please, please involve communities at the very beginning, and that's what Yvonne was saying. Co-design from the very beginning.
Thank you. And that is a wonderful point, and I just want to underscore the other thing you said, which was you can have a wonderful idea, but you have to bring your community along. It can only go as fast as that.
Yes.
Yes. Okay, so now I'd like to open it up to any of the panelists. What do you see to be the major impacts of FDOs for future research?
Well, I can continue from what where I left off. So, as a data scientist, I think I will speak on behalf of my community, if I may so. As I mentioned, we didn't, as a data scientist, I didn't know about FDOs. I didn't know about FAIR principles. Although I worked on verifying data a lot for many years, as George said yesterday, that people were working on verifying data for decades, even before defining the acronym FAIR, but even after that, I mean, even after 2016, I think that's the point in time where we defined as community the FAIR principles. Personally, I worked on verifying data, but I didn't know anything about FAIR, about findability, accessibility, interoperability, and reusability. And I think that we need now to train other communities and to tell them, hey, there is something called FAIR principles, because they don't know that it exists. And I think that this enter community work in order to make, or in order to help the verification of data is really important. Otherwise, every community will work independently without knowing that there is something called FAIR. I mean, we have a project in Germany, NFDA for data science, where we are trying to bring the FAIR principles together with data science and artificial intelligence and bring those two communities together. But even though I think it's not enough, I mean, we have this in Germany, but I don't know whether it's the case in other countries. So I think, I mean, even in this conference, there were many talks, and as mentioned before, we discovered that there are implementations of FDOs, right? Just we didn't know about them. We didn't know that they exist, and we didn't know what people are doing. And I think this conference is a great opportunity to gather people from different communities, and we need to work more on this level to make people aware about the existence of this effort that everyone is putting in order to, make the data or make all the resources fair. Thank you.
So now I'm saying something which might alienate me with some people. What I really have to say that if I look at all these data science centers, they have data science, the discipline, data science, data science mathematics, and they project onto the target case. And I'm always thinking, well, who is writing down equations? Sort of, I think physics has to provide something, but because of the fact that physicists always have to try to generalize things and think across subjects, and that's what I would project in the future. Now I make a bold statement. I think by the end of the century, we might have closed the gap between science and humanities. Because there's this problem, the symbol grounding problem, which 2 years ago I didn't know about. And the fact that I didn't know about it shows the problem of our, I mean, me as a university professor, even working in complexity science, hadn't heard about the symbol grounding problem. And it is the central thing in the humanities, thinking how meaning comes into play. And physicists haven't thought about it. And well, actually, they started to, and I'm not starting to go into that because you can't do this in 2 minutes. But it's sort of, the point is, so I think the first time in his history, physicists will be able to learn from philosophy. I think what Floridi did with his philosophy of information can really, if you read it carefully, you can inspire you and to write down, to make equations of what he is saying. The same thing goes for sociology. There are famous sociologists who write books where there's not a single equation in it, but in fact, if you read their narrative, they call it narrative. So we have to lose our arrogance and think about the narrative and listen to what it's telling you, and you will find length scales, time scales, the effective interactions written down in words. And I close with the statement that words can be as analytical as equations if they are defined well. And if you ever really discuss with a theoretical philosopher of the mind, he is driving you crazy, because what did you say? What do you exactly mean by that? What do you do? If you have the adjective to that substantive, it's something completely different. So if one is serious about the meaning of words, you can convert those words into mathematical statements and actually go the other way. And that is challenging because we haven't learned that. So I think we can quantify the qualitative by doing that.
I wish I was wearing a Schrodinger's cat shirt, or maybe a Shakespeare, to be or not to be. There's so many good T-shirts for your comments there. So any other comments on the future power of FDOs? If not,
yeah, I'd like to actually bring the conversation back to the implementation at the lower level, with FAIR being a goal. So I think FDOs can be one ways of operationalizing the FAIR principles, and they definitely, and if you show some small progress at first, then this is how you're going to get uptake from the community. And with the words, it's been shown how difficult it is to develop ontologies that actually constrain the meaning of particular words in specific context, and how long it takes for people to actually understand that. And it's really necessary, though, like defining the jargon. And there's a glossary of FDOs that I saw flashing in one of the slides from Peter, I believe, early on. And something like that is really useful. What do you mean when you use these particular words? Because if you don't constrain them, then the computer doesn't know what context to apply it to. But that, you know, and you can also do some additional operations in order to extract the context. And that within that context, that specific localized context, you can perhaps apply some more generic principles and generic goals.
Thank you, well said. Would anyone like to comment on the limitations? I think we started that thread, and I wanted to stay with the positive, but what are other places that we need to be thinking about that FDOs are maybe not fully answering, or as described this week, or could do more?
Yeah, so I'd like to also mention you're mentioning, Hans, the politics. So it's very different in the US and from what I understand in Europe, because we already have, I think, 17 federal agencies supporting science, and they all have different missions, different reasons of being, different priorities, and in order to be able to harmonize not just definitions but also requirements for these agencies, it's really hard to come like top down, and then a lot of the work is always done like bottom up. And therefore you have a cottage industry of software that does or doesn't interoperate with various principles that they abide by, or like maybe favoring open science or reproducibility. And I think that with the example of the data management plans, I mean, it's a lot of agencies require that, but there's no way to enforce them. And they've pretty much given up enforcing them because there is no way to actually do it. And even though it's in the proposal reviews, did you put the data management plan? Some institutions, including my own, we have like templates and a Word that's already done, and we stick it in there, and the reviews have already seen it. So how are we going to get out of that conundrum of making requirements, even if the agencies agree with that, without any kind of enforcement? So we go back to incentives.
I really, as a U.S. researcher, I can't relate to that more. Anne or Hans-Günther?
I mean, and maybe I just want to say something about fair digital objects are just objects. So don't forget we have people behind. So don't forget to focus on the people, because on the long term, this is probably what is worth. And that's only what I would like to say, that you tend to always put everything on the technology and on the machine actionable. I'm dreaming about a world where the research will be done by machine and I will have just to put my name on the paper. And then I will have a permanent position probably out of it. It would be great. No, it will be boring. So please don't forget, we want to have fun.
Yeah, I think I totally agree. It's important to get people in the equation, but fair digital objects are actually, if they get active, they're actually more like subjects, because they act, you know, on and interact with the other fair digital objects or with humans. So they are. They're decisively not only objects because they do something. And what I wanted to emphasize, I think we have to be very careful what will be the result of creating that integrated data space. Because with the power of the technique, and especially if in about, let's say, 10 years, we might have already begun the transition to quantum computing, and we have this enormous power of calculation. We need to spend a considerable amount of time, also the scientists doing the research, thinking about what it will entail for society. Because if you suddenly correlate things you have never correlated before, you might not destroy privacy. You might open lids and open boxes of Pandora on an unprecedented case, and I think that is. I'm really worried about that because it's sort of, you know, it's not really clear where we are heading with all that knowledge. You know, I mean, we need to prepare us for difficult decisions, and so be taught in ethics, so that you don't start thinking about. There was a little booklet coming out during the pandemic. It was called disaster. What do you do if you can't decide because there's no decision ground and no time to decide? And they go along all sorts of things what you can do, but at the very end they say, well, the very best thing is actually think ahead before the disaster strikes.
Well, and it's a very good point, and it does sound like, I don't think we had a session this time, but the next FDO conference, something about ethical implications and thinking ahead. Of course, in the news this morning, we had the Twitter news that the sale is complete, and I remember when I started using Twitter, I think I want to say 2007. It was when you had something funny to say and no one was there to hear it, so you put it up, and the next thing you know, it's taking down government. So we should not be shy to think about FDOs, perhaps as a powerful force in the future.
Yeah, talking about people, I would like to add something. Actually, there were a brave and interesting question yesterday. Whose responsibility is this? And I have my own answer. I don't know whether you agree with me or people from the audience agree with me or the whole community agree with me. I don't want to go deep because I'm in early stage of my career. I don't want anyone to hate me. So I think until we don't have an answer, that's what I believe. We don't have yet an answer, clear answer, explicit answer. But until reaching that point, I think it's the responsibility of everyone. I'm talking here in the research environment, so it's the responsibility of the researcher, of the funder at the beginning, the researcher, the organization, the publisher, the editor. So to everyone in this pipeline is responsible of ensuring that the resources are fair. That's my opinion. I don't know whether I would like to know whether you share the same opinion like me or you have comments about my answer to that interesting question.
I mean, I personally agree with you. I think, especially if you also include quality and veracity, I think that is everyone's responsibility. But yes, certainly. Well, and maybe this is a good time to open it up to the audience if you'd like to comment on the thought that was here, or if you have another question, we'd love to hear from you. And there's someone. Okay, so right here. Is that Rainier? Okay. I know your eyes.
So thank you very much, Christine, the panelists, and of course the lightning talks for introducing what you have done and what you're thinking about that. I have 2 comments. I think you're Anne in the middle. Yeah, are you?
Yes.
I didn't get your name, I'm sorry. I just read it from the program. I strongly support, and I'm very, very happy that you pointed out that we need simple explanations of fair digital objects to bring the message. We know that we are working on that. Christine did a kind of a video together with Peter and so on in the FDO forum. Maggie Hellström is also driving that, and it's urgently needed. I would really like to support that. Easy and simple to understand messages, of course, describing the reality. Then I was thinking about dragging scientists out of their comfort zone. And let me reformulate that. With the fair digital objects, we are creating new comfort zones, and we have to make this visible. So for one example, so this would be my elevator pitch in this direction. Fair digital objects are trusted objects. We create trusts, which means when I'm creating a fair digital object, I can trust the infrastructure that it stays the same. As well, if I'm reusing a fair digital object, I can trust that the contents and the quality are being described and I can use it. Thank you very much.
Thank you so much, Rainier. And I'm really liking this future direction where the papers are going to be written by the computer and I'm going to have new comfort zones. This sounds double thumbs up.
Good, yeah.
Okay. Yes, please, Mark. Yes, a mic is coming to you.
Sorry for being a techie, nerdy one now, but I want to go back to what Lena said about streaming. One of the things I've noticed about fair digital objects is they're very static. Here is the object, plonk, that's it. The real world isn't like that. The real world changes over time. So if there was an element, I come from a digital twin background, so this is what we deal with. Digital twins create data over time. They publish stuff as they change their state. So a fair digital object at the moment might be, oh, well, I'm researching this paper, I'm writing it up, I'm collecting data. Maybe you could have a status update coming out of it like that. Or, as Lena said, why not have fair digital objects of sensors and other equipment that is publishing in real time? Because one of the things I've learned is it's much, much easier to analyze data in real time than it is to go back over it historically and try and work out what it meant. You know, it's too hot right now. Okay, it's too hot. Rather than going back over the last 20 years going, well, what does too hot mean? Sometimes you really need that on-the-fly stuff. That sounded more like a comment than a question, sorry.
No, we love comments, so Stan, and then we'll come to Rob in the front.
Hi, let me first say one thing maybe. So I'm not an academic, I'm a standards guy, and I'm pretty new to this community. I've heard the term fair digital object for the first time maybe 1 year ago. And I must say, I'm really impressed about this conference, and I would congratulate the whole community to this conference. But now in this discussion, there's been some mention on leaving silos, approaching other communities. And my question to potentially all panelists would be how you see the relevance of FDOs beyond the research community. So looking at government, looking at industry, and potentially other applications. Thank you.
Sure. Would anyone in particular like to? Yeah, Hans, I was hoping you would.
Yeah, actually, I think that the impact will be strong, because what we do in the academics will be not done again. new. It will be taken up by society and it will be taken along by industry. So I think what the responsibility of the scientific community is pushing and start the transition going. And I think we have it in our hands to in a certain degree give out the direction. And the great thing about fair digital objects is because they implement the similarity. They have these built-in symmetries. They are analogous to mathematical categories, which opens up a vast array of usage. And whether you describe the traffic lights in a city or the waste bins, if you think about it, how they are structured, basically this is just the same thing at a certain level. And even if you compare, there's this canonical workflows of research. I think you can cross out the word research and say, Verwaltung is what I miss a English word now. Help me.
Administration?
Administration, yeah. Typical workflows of administration. So I think when you think about it, if you produce an object in the industrial line, you have some product, you add something, you do something to the object, and you put it out on the other side. Just the implementations of what you do exactly is different. The logic at a high level, the higher up level, and I believe probably already at the second or third layer, it doesn't matter if there is what's exactly down there. So, for instance, in networks, it's not at all relevant what is flowing. It is responsible. What's important is the time scale, the length scale, and the topology of the network. And all the rest is, does something at the linear level, scaling something, but it's not changing power laws and the real and transitions. That's just the same.
And the reason I look to Hans-Günther is in Germany, there's been great engagement from the German government, members of parliament, and also industry and manufacturing. So thank you for commenting. Do you see any thought bubbles?
Just to add one thing, I think if we put our hands on the problem in the industry, I mean, the main problem or the main discussion now is about data sovereignty and ownership of data. And if FDO can solve this problem, I think it would be a great asset to the business community or the industrial community.
Definitely.
I think the service layer can do that. I mean, it's building an extremely good way of putting rights and demands in a very flexible way. I think this is exactly what we want to have.
Go back to one of the things you were saying earlier, and maybe go back to this idea of the definition of what is a digital object, because in the quantum world, for instance, what is a digital object? And let alone a fair digital object. Is this a byte flip? Is this a collection of byte flips? Is this a position on the quantum topography? At that point, it becomes very difficult. So this is also something like that is related to, like the streaming objects that somebody was mentioning earlier. So is like if you take a time series, for instance, that where you have like a fixed collection, but you keep adding elements to the time series. How do you find the part that you're interested in? So it goes back to the definition of the digital object and in the quantum world. What is this going to mean?
I was hoping to be retired before quantum computing came in, but okay.
That's an interesting point. Yes.
George actually made a remark on that. He said that he would like to see FDOs in the abstract way, and if we discuss like that, we have it more easier to adapt it to the quantum version, and we in our consortium try to think about it actually, because I don't think it will in 10 years. I think we'll. I mean, you can already You can work on a quantum computer next week if you apply.
Sure, but you're a physicist, so you might have a different perspective on this. But yes, a point well taken. I think, Rob, you had a question, and then I had someone over here, and I'll try and get over to Carol and Ivonne if there's time. We have 3 minutes to go, so punchy questions, please. Punchy questions and answers. Which goes with the, I guess we're getting a little bit aggressive. We're breaking people out of silos and...
This is really hard. So I first wanted to comment on the fact that digital objects are static. I don't think they necessarily are. If you look at the proposal that Bob Kahn made for digital objects and read the digital object interface protocol specifications, you can see that there is not only getting digital objects, there is operating on digital objects already there from the beginning. And for me, digital objects in the internet is this similar to having a file on your computer. You don't only read the file and then write another one. You can actually operate on files and change them. Of course, this needs to be well defined. But my primary reason to raise my hand was actually to compare digital objects with, fair digital objects, with electricity. In the beginning, there was a nice fight between Tesla and Edison about direct current or alternating current. And they even tried to frighten the world for the alternative. And what we are seeing now is that nobody needs to know anymore how it works, or at least engineers do. But I just flip a switch if I want to have the light on in my room, or I talk to Siri and I ask her to turn the light to more bright yellow, and it works. I don't need to understand what electricity does. And I think the similar things can happen to fair digital objects. Maybe a large part of the engineers that are here in the room need to know how they work. But in the end, like every programmer now uses open, seek, read and write and append functions to change files, we have operations on fair digital objects in 10 years. And we know how to work with them, no matter how they are implemented.
Excellent point, Rob. Okay, I'm so sorry. I think we just have, and I don't know which of you can fight it out for which of you gets the mic. How's that? Yeah. Oh, yeah. Please. Yeah.
Yeah. A direct follow-up on that, and that is that we should view objects the way objects are in object-oriented programming, right? Who has ever programmed in an object-oriented programming language? Raise your hands. Okay. Then you know that an object is something you can ask questions, it gives you answers, but you can also attach operations to it. Objects can, in a way, do things. You can activate certain procedures. Objects could even potentially update themselves, present themselves in different ways, and so on. So, I mean, objects are anything but static. And also, it would solve a question that I think Erik asked, what do you do when you have like thousands of objects that are similar? Well, you create an inheritance hierarchy, for example, and that's a way to promote efficiency in handling it. So let's think of objects like fair digital objects as a kind of objects in an object-oriented programming language.
Thank you. Great point. And now if we can end with Yvonne and Carol, one of you like to, or both of you give quick thoughts, then we'll close out the session.
Thank you so much. So as a quick thought, diversity, this is a social enterprise. So actually all of the speakers really spoke about that as a social enterprise. And there's an entire community that understands how communities work, how socialization happens in order to be able to deliver software, to deliver new ideas and so on, particularly from the information sciences field, from the, the Christine Borgman and her kind of community. There's even a conference called the Science of Team Science, which is in its 17th year, right? And I think it's important for us to actually say, how do we use these kind of principles? How do you build communities? How do you get engagement? As part of those people, as part of the team that was being mentioned, the one team that we're going to put together of users, developers, everybody, in order to be able to move this whole enterprise forward, because it's not a technical issue, it's a social enterprise issue.
And final thought, Yvonne. Thank you so much, Carol. Great point.
So actually, it pretty much fits what you said. I think communication is quite important. When you said data management plans, it was just things you don't want to do. I think the wording data management plans, it is not coming from the community. So they would never name it like this Carsten and me, we always sell it as a project brain, this document. So it is much easier to understand for the people. And I also think that if you want to include the communities, probably fair digital objects is not the best thing. So trust objects I liked a lot. So something that the people feel more familiar and they would like to work on it if the name is maybe more, they like it more if it is not. Often something like that, yes. Okay.
Thank you so much. Well said. Well, with that, I'd like to thank the panelists and all of the Lightning Talk speakers.